For this first type of problem in this classwork, it's not asking me to actually apply the quadratic formula. It's just asking me to get used to identifying what a, b, and c would be. A is always in front of the x squared term, b is in front of the term with the single power of x, and c is the number that has no x attached to it whatsoever. So ideally, they'd be in the form like a is, where I have x squared, then single power of x, then no power of x. If they are in the right order, then a, b, and c are just the coefficient in front of each term. So an understood 1 is in front of this x squared, that's why a equals 1. There's a negative 5 in front of the x, that's why negative 5 equals b. And there's a positive 3 with no power of x, that's why c equals 3. Same idea for b. I take what's in front of the x squared, I take what's in front of the x, and I take what has no power of x, and identify them as a, b, and c. The third problem is a little trickier because it doesn't currently have it solved for equal to 0. You want to make sure whenever you do solve one of these as equal to 0 that the x squared term is positive, so I want to take everything to the side that would make the x squared positive. In this case, that would be taking everything to the right side. So I'm going to subtract 3x here, subtract 3x here. Over here, I'll be left with 0. On the right side, I have 8x squared minus 3x plus 2. I now have them in descending order, x squared, single power of x, no power of x, so I can identify them as a, b, and c. A equals 8, b equals negative 3, c equals positive 2. When we go to use the actual quadratic formula, we still have to do what we did above first, identifying a, b, and c. So here, a equals 1, b equals negative 6, c equals 8. Now that I know a, b, and c, I need to plug them in to solve for x. So in this case, x equals negative b really means the opposite sign of b. B currently is negative 6. The opposite of negative is positive, so negative b is really a positive 6. Plus or minus really tells me that there's going to be 2 answered. The square root of b squared, negative 6 squared, minus 4 times a, which is 1, times c, which is 8. All over 2 times a, which is 1. If I clean this up a little, this becomes 6 plus or minus the square root. Negative 6 squared is 36. Negative 4 times 1 is negative 4. Times 8 is negative 32. Still all over 2a, which is 2. This becomes 6 plus or minus the square root of 36 minus 32 is 4 over 2. Because the root of 4 is a perfect square, it can come out as 2. So this becomes x equals 6 plus or minus 2 over 2. When it comes out as a perfect square, we want to see what the 2 possible answers are by first following the path where we use a positive on top, then following the path where we use a negative on top. So the first one becomes 6 plus 2 over 2. The second one becomes 6 minus 2 over 2. I always want to make sure I do the addition or subtraction on top before I do the division. In this case, 6 plus 2 gives me 8, which is then divided by 2. 6 minus 2 gives me 4, which is then divided by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. So my 2 answers are x equals 2, comma 4. When I apply the same principles to b, I start out by identifying a equals 1, b equals 3, c equals negative 10. I then set up x equals negative b, in this case negative 3, plus or minus the square root of b squared, which is 3 squared, minus 4ac, so minus 4 times 1 times negative 10. All over 2a, or in this case 2 times 1. If I clean it up a little, this becomes negative 3 plus or minus the square root of 9. 3 squared gets me to 9. When I do negative 4 times 1, I get negative 4. Negative 4 times negative 10 gives me a positive 40. All over 2 times 1, which is 2. This becomes negative 3 plus or minus the square root of 9 plus 4 is 49 over 2. Well, the square root of 49 is a perfect square. Square root of 49 is 7. So this becomes x equals negative 3 plus or minus 7 divided by 2. We need to go down both paths. So the first path is when we use a plus sign. There we get negative 3 plus 7 over 2. Second path is where we use a minus sign. There we get negative 3 minus 7 over 2. When we add negative 3 and 7, it's a positive 4 over 2. Negative 3 and negative 7 is a negative 10 over 2. 4 over 2 equals 2. Negative 10 over 2 equals negative 5. So my final answers for x are negative 5 and 2. When I attempt this problem, I begin by pulling out what a, b, and c are. A equals 1, the understood in front of the x squared term. B equals 5, and c equals 11. I can now plug into the formula, where I'm going to get x equals negative b, the opposite of 5 is negative 5, plus or minus the square root of b squared, which is 5 squared, minus 4ac. In this case, a is 1, and c is 11. All over 2 times a, which in this case is 1. When I clean that up a little bit, the negative 5 stays outside, plus or minus the root of 5 squared is 25. Negative 4 times 1 is negative 4, times 11 is negative 44. All over 2. This becomes negative 5 plus or minus the square root of 25 minus 44 should give me negative 19. All over 2. At this stage, I see that under my root, I have a negative answer. Technically, this only gives me imaginary roots. Since we're looking to find all real solutions, these don't count as real solutions. They don't count because I can't take the root of a negative number. So if b squared minus 4ac underneath this radical gives you a negative number, you can stop right there and say there's no real solutions. So the way you should write it in the Cengage is no solution. When I go to try the fourth example here, I again can pull out that a equals 1, b equals 2, c equals negative 7. If I now set up my quadratic formula, x equals negative b, in this case negative 2, plus or minus the square root of b squared, 2 to the second power, minus 4 times a, which is 1, times c, which is negative 7. All over 2 times a, which is 1. Cleaning it up a little, I get negative 2 plus or minus the square root. 2 squared is 4. Negative 4 times 1 is negative 4, times negative 7 is positive 28. A negative times a negative gives me a positive. Still all over 2. This equals negative 2 plus or minus the root of 32 over 2. I would leave it there. Really, I would just write it two different ways. The first way as negative 2 plus the root of 32 over 2, and the second way as negative 2 minus the root of 32 over 2. I could use what we learned in 8.3 to simplify this, and instead of being root 32, I could write it as root 16 times root 2, which would make it into 4 root 2. If I did that, I'd get negative 2 plus 4 root 2 over 2, and negative 2 minus 4 root 2 over 2, where in this case 2 would divide into everything, so I'd really get negative 1 plus 2 root 2 and -1 minus 2 root 2. I'm pretty sure that right here they'll accept your answer. You also might be able to get decimal answers where if you put this into your calculator, making sure you have parentheses around the top, it'll give you a decimal answer that I believe will be accepted. If you think you're doing everything right and it's not accepting your answer, as always, send it to me as an Ask Your Teacher and I can take a look. But basically, these are the 2 correct answers. These are simplified forms of those 2 correct answers. When I get to part E, I can't just pull out A, B, and C like I did above, because I don't have them set to 0 like I did above. I first need to move this +1 by subtracting 1 from each side. That gives me 5x squared minus 4x minus 1 equals 0. Now that I have everything to the same side equal to 0, I can pull out A, B, and C. A equals 5, B equals -4, C equals -1. I put them into the formula. X equals the opposite of B. Since B is currently -4, the opposite of that becomes +4, plus or minus the square root of B squared, or -4 quantity squared, minus 4 times A, which is 5, times C, which is -1. All over 2 times A, or 2 times 5. This becomes 4 plus or minus the square root. -4 squared is 16. -4 times 5 is -20. -20 times a -1 is +20. All over 2 times 5, which is 10. 16 plus 20 is the root of 36. So I get 4 plus or minus the root of 36 over 10. Root of 36 is a perfect square, so I get 4 plus or minus 6 over 10. I can now take this 2 different ways. So x equals, first way is 4 plus 6 over 10. Second way is x equals 4 minus 6 over 10. When I do it the top way, 4 plus 6 gives me 10. 10 divided by 10 gives me 1, which is my first possible answer for x. When I do it the second way, 4 minus 6 gives me -2, also over 10. This can be reduced by dividing top and bottom by 2 and leave me with -1 over 5. So my final answers for x are -1/5 and 1.